Now, let us use the formula for double angle just to solve the equations of this nature. In this case, theta I can find out between 0 to 360 degree, and the equation is cos theta is equal to, we will see what are the values, they are very interesting, and I have taken intentionally this equation just to show you well how many values are coming for theta. So, cos theta is 3 times cos 2 theta plus 2. You write down is it as 6 cos square theta minus 3 plus 2, and that is simply an equation involving cos square theta and cos theta, and that is this is a quadratic equation in cos theta. Now, 2 cos theta minus 1 into 3 cos theta plus 1, that is the simple factor, is equal to 0. So, this gives you from first bracket 2 cos theta is equal to 1, that is cos theta is equal to half, and cos theta is equal to half in between this range, that is 0 and 360. The value of theta will be 60 degree as well as 300 degree. Similarly, for cos theta is equal to minus 1 by 3, well, this will give you theta is equal to either 109.5 or 250.5, but if you do not want to use the table, then of course, it will not be possible for you write down the two last values of theta. So, most of the time, because you are just at the beginning stage, you are usually supposed to write down the standard values for let us say the values of theta. So, these are the just summary which I have already mentioned. Now, let us see the same type of formulas you can find out with the help of these formulas, and they are also very standard formula, and before the radical or the square root I have taken plus minus in all the three cases. So, but you have to see, this is very important, which sign you have to choose. So, they are not both plus and minus, but you have to find out where the terminal side of the angle is and put on the appropriate sign for that quadrant, because what is the angle alpha by 2, and you have to be very careful using that fact. Well, in first quadrant all are positive, in second sine is positive, in third tangent is positive, and in fourth your cosine is positive. So, you have to be very careful, because either plus is to be taken or minus is to be taken depending upon the quadrant in which your alpha by 2 is lying. So, this expression, the very first expression is sin alpha by 2 is equal to 1 minus cos alpha upon 2, and the value of cos alpha by 2 is equal to plus minus square root 1 plus cos alpha by 2, and the third is just merely the consequence of the first two, and the question is how to derive it, and that is very simple. Let me derive you within no time, they are in fact trivial. So, let us find out. Well, recall cos 2 theta is equal to 2 cos square theta minus 1. So, here you choose theta is equal to alpha by 2. So, this gives you cos alpha is equal to 2 cos square alpha by 2 minus 1. So 1 plus cos alpha, you bring it on this side, divide by 2 is equal to cos square alpha by 2. So you take the square root 1 plus cos alpha by 2, this is equal to cos alpha by 2, and that is your plus minus. So this expression you get for cos of alpha by 2, and similarly if you write it as, this is also equal to 1 minus 2 sin square theta. So cos 2 theta is also equal to 1 minus 2 sin square theta. So this will give you the expression for sin theta by 2. So this becomes cos alpha is equal to, well, parallelly I can write it as 2 cos square. So this is 1 minus 2 sin square alpha by 2. So using this you will get plus minus square root 1 minus cos alpha by 2 is equal to sin alpha by 2, and if you divide the 2, so this upon this you will get the expression for tangent of alpha by 2. So let me once again come back here. Sin alpha by 2 is this, cos alpha by 2 is this, and there is no need of this proving with this tan alpha by 2 directly, because we have already shown it for sin alpha by 2 upon cos alpha by 2. But nevertheless, if you write down the expression tan square alpha is equal to 1 minus cos 2 alpha upon 1 plus cos 2 alpha, then your third formula can be simply obtained. So it is up to you which technique you follow. So tan alpha by 2 you can write in terms of this sin alpha and in terms of cos alpha. So these are the half angle formula for tan alpha by 2, because 1 already I have derived, and 1 minus cos alpha is your, what you call, you write down the value of cos alpha now, that is your 2 cos square alpha by 2 minus 1, and just simplify, you will get it sin alpha upon 1 plus cos alpha. So you can find out these expressions for sin 50 degree using the half angle formula, because you have already derived it by using the formula sin of a minus b, because sin 15, that is, you can write as 45 degree minus 30 degree, or as if your choice 60 minus 45, and both are to be the known values. But if you want to use the half angle formula, then you can find out this value just by considering the formula which I have just shown to you. The first is sin alpha by 2 was your plus minus square root 1 minus cos alpha upon 2. So in this case I am choosing alpha as 30 degree. So 15 degree, that will be the half of alpha, and I have shown it with the help of this arrow, because 15 degree in the first quadrant, so sign is positive, therefore we have ignored the minus sign. So sin 15 degree is 1 minus cos 30 upon 2, that is 1 minus square root 3 by 2 upon 2, and that you can write square root 2 minus square root 3 upon 4, but square root of 4 is 2, and that is your square root of 2 minus square root 3 divided by 2, and if you compare the two results you will get this thing. Now there are certain other exercise. If sin theta is this, find the value of sin 2 theta, but theta I have taken into the let us say second quadrant. So I have to be very careful, because in second quadrant your sign is positive, but the rest will be negative. That is why your cos theta I have taken as minus 3 by 5. You have to be very careful for the signature. So, that is why I have written it completely, because if sin theta is 4 by 5 and if you form the triangle, then usually you get cos theta is 3 by 5, but that 3 by 5 is in the case when your theta is lying in the first quadrant, but theta in this case is I am choosing to be between pi by 2 and pi. So, it is in the second quadrant, and in second quadrant your cosine has to be negative. So, similarly the same question, here you have to find out the value of sin theta by 2, and you simply use the expression that sin theta by 2 is 1 minus cos theta upon 2 is square root. Why positive? Positive is to be taken because sin is there and sin is always positive in second quadrant. So, you will get after trivial simplification, the value of sin theta by 2 is equal to square root 1 plus 3 by 5 upon 2, and you will get is just square root 4 by 5, and square root of 4 is 2. So, 2 by root 5 and multiply and divide the numerator by square root 5. So, you will get it to be 2 root 5 upon 5. So, once again I am stressing upon one thing, that you have to be a bit careful regarding the signature of the expression which you are evaluating, and that is the table which I have given. Then in first quadrant sin, cos, tan all are positive. In second only sin is positive, cos is negative, tan is negative. In third sin, cos both are negative and tangent is positive, and in fourth sin is negative, cos is positive and tangent is negative. So, you can take the help of this chart. I am not considering regarding that cot and secant and cosecant, because they are the reciprocal of these three quantities. So, that is the same thing. If tan is positive, obviously cot has to be positive, and if it is negative, then cotangent has to be negative, and so on. Then finally, this is simple exercise for you, because you use here the formula for 2x plus x, and once again I have given the hint, use the formula of sin a plus b. So, this is sin a cos b plus cos a sin b, namely sin 2x cos x plus cos 2x sin x. Write down the expression for sin 2x, that is 2 sin x cos x into cos x plus 1 minus 2 sin square x into sin x. I have taken the expression cos 2x as 1 minus 2 sin square x. Why? Because I want everything in terms of sin, and just simplify it, that is 2 sin x into cos square x plus sin x minus 2 sin cube x, and cos square x I will write as, let us say, 1 minus sin square x, and I simply simplify, that becomes ultimately 2 sin x minus 2 sin cube x plus sin x minus 2 sin cube x, and finally I get it sin 3x is equal to 3 sin x minus 4 sin cube x. Cos 3x I have already derived, that is just the repetition, that is simply the exercise. So, you see the steps and you get 4 cos cube x minus 3 cos x. So, these are your final expressions. I have already derived each of them except the cotangent tan theta, and that is nothing but the reciprocal of the expression which I have shaded in, let us say, yellow color. And these are some exercises for you. So, they are in fact trivial exercises simply based on your standard formulas. And thank you very much. So, I have summarized all the results with the help of examples also, and most of the time I have derived these expressions. And finally, thanks a lot for listening me so patiently. Thank you.